In the last lesson, we looked at how the current through a wire varied with the PD across it. We found that the current was directly proportional to the PD, so the wire obeyed Ohm's law. Ohm's law only holds for wires that don't get too hot. A filament light bulb has a very thin wire, the filament, that's designed to get so hot it glows, which is what produces the light. This means filament light bulbs don't obey Ohm's law. So we have to do an experiment to find out how the current through a given bulb changes with the PD across it. We're going to use a variable resistor to change the PD across the bulb and the current through it, rather than a variable voltage supply like last time. This is the basic circuit, a variable resistor in series with a filament bulb. When you change the resistance of the variable resistor, the bulb gets brighter and dimmer because the temperature of the filament changes. We can measure the current through the bulb by breaking the circuit and inserting an ammeter. Then we can connect a voltmeter in parallel with the bulb to measure the PD across it. By moving the slider, we can change the PD across the bulb and measure the current through it. If we take pairs of voltage and current readings, we end up with a table that looks like this. Which we can use to plot a graph of current versus voltage. We can see that the graph isn't a straight line through the origin, so the filament bulb definitely doesn't obey Ohm's law. We'll find out what happens to the resistance in part 2.